Good afternoon. Today we're going to talk about the BIM and actual reality, which is one of the extended use of BIM. Firstly, I will talk about the BIM and its extended use. Building information modeling was introduced to the AEC industry, and the concept of BIM is to create and utilize the digital building model into the construction and to integrate different kind of project information into a database, etc. Normally, BIM has different kind of characteristics. The first one is to utilize the 3D model to capture, explore, and maintain the building data. The second one is to provide a greater project insight for cost schedule. Number 3 is to share the same consistent data. Number 4 is to enable the prompt response. As you can see, the BIM can be applied into different construction phases. For example, the design, construction, planning, programming, or even the renovation phases as well. BIM drones is one of the typical examples which combine the two concepts, using the drones for the permanent construction records, and you can assist with creating 3D models in the BIM model as well. Now I will talk about the BIM AR concept. BIM AR is a mixture of the virtual and the real environment, which the AR allows an experience of a virtual mixture or object to be displayed in the BIM model, and the mixture can provide an additional layer in a mobile or devices to showcase the building information. And it can provide information in the operative perspective, for example, the installation location of a pipe and cables. There are 3 types of BIM AR. The first one is the tabletop BIM AR, which register and track the marker of the engineering plan and generate the digital content to be displayed in the marker. The second one is the portable AR BIM, which the BIM track the specific features, for example, of particular pipe, and it can be changed by tracking the user movement and motions. And the final one is the remote monitoring BIM AR, which the calibration will be conducted through analyzing the video or picture taken virtually, and this is very convenient to manage the site situation in a remote state. The corresponding software is also crucial to the BIM AR, which the BIM model will be exported to a 3D powerful engine platform.
To further investigate the feasibility of integrating BIM into the construction industry, we have carried out an experiment with the use of HoloLens, a mixed reality smart glasses developed by Microsoft. By demonstrating a fully articulated hand tracking system, HoloLens allows workers to easily drag, enlarge, or move a particular component for alternations or design. It also keeps track of the user's eyes movement, which shows images or applications on a specific area on a virtual screen. Actions will be implemented according to our voices as well. Not only does HoloLens recognize the user, it also recognizes the space. During our experiment, when 2 people put on the glasses at the same time, we are concurrently seeing the same object. So when someone spots mistake in the early design stage, everyone in the team can be notified by looking at the same setting, which minimizes on-site problem. In terms of operation, different functions compatible with HoloLens includes camera, settings, Wi-Fi connection, etc. Also, the window tab shown on the slides is almost transparent and merges with the surrounding. It ensures the safety of workers as they can stay alert to the changing environment. To select or tap, the major hand gesture is pinching. To return to the previous page, a finger press gesture will do. Other hand gestures of the model are shown on the slide. Although we did not have the opportunity to simulate AR technology in a real setting, the construction of the head office in Finland is a great example to identify the connection pipes, beams, and columns using HoloLens. The topmost selection on the tab is to hide virtual component. This function allows the construction professionals to virtually take a glance of the before and after situation of the building surface installation in advance. However, we have experienced some limitation when using HoloLens. First, when we were moving from one gesture to another, the tab could not catch up with the order and there is a minor delay for 1 to 2 seconds. Although a remote control is accessible, there is only one button for option selection, which is not as sensitive as our hands for sure. Second, when we place a fast-moving object like a human running in front of the lens, the window tab suddenly disappeared. While the lens works perfectly with a still background, it should not be neglected when speedy movements are present in a construction site. We've also experienced failures in detecting different voices. The system could only detect the first user's voice, whereas subsequent voices are not able to be recognized. After conducting a hands-on experience with HoloLens, we've concluded that the sensibility of the system could be improved.